Today, I'm gonna fly the R3 Pro V2 on these power lines behind me to see how well it does. Let's go. And there we go. Okay, so I got the R3 Pro on the M350. Now I'm gonna do some mission planning. We're gonna fly this power substation. All right, guys, I got the mission plan I just finished doing here. So I'm doing 70% side overlap. I'm gonna fly at 150 feet. And how fast am I gonna go? We're gonna go right at 4.5 meters per second today. So that's a total of 24 minutes and 33-second flight plan. There you guys go. Okay guys, so now I'm controlling the LiDAR through the Rock Pilot app. So we can see all the settings of the LiDAR. Now it's collecting data. So now we can go ahead and take off and start flying our mission. Okay, another beautiful day flying. Now let's go back to the house, take a look at that data set. Now welcome back to my office. I just finished processing that data in Rock Desktop, uploaded it to Rock Cloud, and now we're gonna take our first look at that data set. Let's jump into it. So here we go. This is the data set that we just got done flying. I can actually, a couple things before we dive into it, I wanna point out over here on the layers, we got the trajectory that we flew, so you can see that there. And then we can also turn on all of these inspection photos. So we can actually jump in here and click on any one of these and bring up this photo that we can really zoom in and see the high resolution detail of the objects that we're seeing in the 3D data. Now, before we jump in and really dive deep into this data, there's a couple things I want to show you. One was that inspection tool. They call it Rock Inspect. It's really cool. And the other thing is the orthomosaic that's generated from this as well. I actually went out to this site to fly the R3 Pro V2 to generate the orthomosaic because I knew this is going to be a very difficult thing to make an orthomosaic out of. So how will rock photogrammetry perform? So that's really one of the big questions I have with flying this mission. And then also just looking at the colorization and the accuracy of those power lines and the wires here in the R3 Pro V2. Okay, let's get back into it. I'm gonna go ahead and turn off those photos and the trajectory, and we can zoom down and just start looking at some of the data. That looks pretty darn good, in my opinion, objectively. So a couple things I'm gonna look at. So these footers here, I just wanted to see how well, I mean, it looks like it's a perfect right angle there. So that's looking really good. Really flat, really smooth, really crisp. This is all, again, from that 45 meters in the air, I believe. Let me pull this up again. Yep, 45 meters, 5 meters per second, 7% side overlap. And some of the things I looked at on previous videos, I flew the same site. I was looking at two wires that were really close together, and how good does it look on here? I would say that looks phenomenal. Better than what it used to look like with the R3 Pro V1. Definitely better than any of the Avia sensors like the L1. I remember looking at that data set. We had a lot of errors there. Overall, I think this just looks pretty gorgeous. And the colorization, just seeing how well these insulators are lined up and colorized, and the wires, everything is turning out pretty good. You can definitely pull out many features, anything you need from this, and get all of that usable data. Now, actually right here behind me, let me zoom out a little bit because there was a cell tower, yeah. So I didn't even really know to capture this, but I know one of the things is like looking at the angles of the where these antennas are pointing. And I think you can, I mean, we just flew over this really fast, right? One pass. You can definitely grab the angle of these antennas and where they're pointed. So that's just an added bonus, I would say. Looking at the colorization down here, just everything looks spot on. Okay, let's go ahead and flip over to the orthomosaic that was generated and start diving into that. So I can click this button here on the top. That's going to take me over to this 2D view. And you can see the ortho is just loading. Beautiful, and it's done. So far, it's looking really good. Now, the thing about the rock photogrammetry is that everything is being forced to go into this nadir perspective. That means straight down from above. What that means is that if I were to say, draw a point here to find this column or whatever's holding up this crossbar, that would be the XY location of that object in the real world. So same thing with anything along these lines, that would be the XY location. Now you can see some things happening, this little inaccuracies, and that, I mean, it has to be from the perspective. You know, like the photos being taken from the left or the right of these objects, but in the 3D data, in the 2D data, I mean, we're trying to force it to be only nadir. So my assumption is that there actually just wasn't a photo from that spot. Because if actually we look on the flat ground, everything looks perfect there. And then we just look at this, the wires and stuff, and you see they're forced to be in that location. This is very impressive. I did not expect it to do this well, to be honest. This is like the most intricate, complicated thing for the rock photogrammetry engine to handle. And to see how well it is doing on this type of data set, I would say this is a huge win. Obviously, there's room for improvement. I think the rock engineers will definitely keep improving on this. I know because I am the CEO of the company, so I talk to them every day, and we are improving on it. But this was a challenge, and I wanted to go and throw a curveball at the data set and to go and fly this just so I can see, like, hey, this is, to me, the most challenging thing for the rock photogrammetry engine. And to see the results of things are located in the correct location, in that nadir direction, and then looking at the resolution, this is, again, from 45 meters in the air. You know, it's pretty darn spot on. You can actually see this is where 1, 2, 3 photos are all coming together. And you can't even, everything is a continuous, no seam. Got some objects here, some building supplies, materials. I mean, if I flew a little bit lower, I could probably tell you exactly what these things are, you know? And then there were some trees on the edge, and I know some people ask me about trees, like how does rock photogrammetry do at trees? And here you go. That's how it does. So actually, this is all of the tree from the tree canopy from the nadir direction. So this would be like a complete overhead shot of the trees, and you'd be able to see exactly where those were. And someone pointed this out to me. So this is actually like a fire training facility. So I think this is a test dummy for practicing. This isn't nothing nefarious going on over here in the outlands. No, that's just all good. All right, I want to take one last look, because one last thing about the 3D data and then coming over into the 2D data is you can do things like, let me just drop a marker on, let's call that just pole. And if I save that, I come over here and you can see there's that point right there on the orthomosaic. So you can see, looks like I tagged right here on the edge. Let's actually take a look at it and see I actually am on the edge of this pole. So you see that? I actually accidentally grabbed that point on the edge. And if you come over here into the orthomosaic, it's actually on the edge of the pole. That's exactly where that edge is at. So now you can see what I'm saying. That's grabbing that true nadir perspective. Even on those 3D objects like this, it's still going to grab that XY location on your flat orthomosaic. Pretty cool. All right, guys, this data set is available in the description below. You can click it, you can view it, you can play with it yourself, you can share it with anyone. We always want to be open and transparent with our data sets here on Indiana Drones and Rock Robotic both. But this was a fun one to fly. Give me some suggestions down below. What do you want to see me fly next, or slam, indoor buildings, or do mobile mapping, or experiment with different configurations of all the above? All right, guys, I hope you had a very knowledgeable experience on this, and I hope you like, comment, and share. And I'll see you here next time here on Indiana Drones.